Hello guys, in the previous lecture we discussed the simulated PV characteristic of solar cell. Now this is the part for my series renewable energy resources. Now let us take over 95% of all the solar cell produced worldwide are composed of the semiconductor material silicon. As the second most abundant element in earth, silicon has the advantage of being available in sufficient quantities. To produce a solar cell, the semiconductor is contaminated or doped because by doping we increase the conductivity. Doping is the intentional introduction of chemical element into the semiconductor like n-type doping, p-type doping. By doping this depending upon the type of dopant, one can obtain a surplus of either positive charge carrier called P conducting semiconductor layer positive or negative charge carrier called N conducting semiconductor layer. Material of solar cells are composed of various semiconducting material. First crystalline silicon, second cadmium telluride, third copper indium diselenide, fourth gallium arsenide, fifth indium phosphide, or sixth zinc sulfide. Note, semiconductors are material which become electrically conductive when supplied with light or heat, but which operate as insulator at low temperature. If two differently contaminated semiconductor layers are combined, then a so-called p-n junction result on the boundary of the layer. N-type semiconductor, p-type semiconductor. This is the p-n junction the line shows. By topping prevalent element, we get p-type semiconductor with excess amount of hole. By doping pentavalent element, we get n-type semiconductor with excess amount of electron. Photovoltaic effect definition: the generation of voltage across the p-n junction in a semiconductor due to the absorption of light radiation is called photovoltaic effect. The device based on this effect is called photovoltaic device. N-type, p-type, p-n junction sorry electron hole formation. Photovoltaic energy conversion relies on the number of photons strike on the earth. Photon is a flux of light particle. On a clear day, about 4.4 into 10 power 17 photons strike a square centimeter of the Earth's surface every second. Only some of these photons, those with energy in excess of the band gap, can be converted into electricity by the solar cell. When such photon enters the semiconductor, it may be absorbed and promote an electron from the valence band to the conduction band. Now, this is diagram conduction band. Electron holds from valence band towards electron. This is the photons. Therefore, vacant is created in the valence band and it is called hole. Now, the electron in the conduction band and hole in valence band combine together and forms electron hole pair. Solar panel or solar array. We discuss solar panel. So, single solar cell. The single solar cell constitute the n-type layer sandwich with p-type layer. The most commonly known solar cell is configured as large area p-n junction made from silicon wafer. A single cell can produce only very tiny amount of electricity. It can be used only to light up a small light bulb or power a calculator. Single photovoltaic cells are used in many small electronic applications such as watches and calculator. Single solar cell n-type, p-type, and this is the symbol of battery. Solar panel or solar array or solar module. The solar panel or solar array is the interconnection of number of solar module to get efficient power. A solar module consists of number of interconnected solar cells. This interconnected cell embedded between two glasses plate to protect the bad weather. Since absorption area of module is high, more energy can be produced. Fifth, types of solar cell. Based on the types of crystal used, solar cell can be classified as monocrystalline silicon cell, polycrystalline silicon cell, amorphous silicon cell. First, the monocrystalline silicon cell is produced from pure silicon single crystal. Since the monocrystalline silicon is pure and defect free, the efficiency of cell will be higher. In polycrystalline solar cell, liquid silicon is used as raw material and polycrystalline silicon was obtained followed by solidification process. The material contain various crystalline sizes, hence the efficiency of this type of cell is less than monocrystalline cell. Third, amorphous silicon was obtained by depositing silicon film on the substrate like glass plate. The layer thickness amount to less than 1 micrometer. The thickness of a human hair for comparison is 50 to 100 micrometer. The efficiency of amorphous cell is much lower than that of the other two cell types. As a result, they are used mainly in low power equipment such as watches and pocket calculator as a facade element. Comparison types of solar cell: monocrystalline silicon 14 to 17% efficiency, polycrystalline में 13 to 15 efficiency, amorphous silicon 5 to 7. Principal construction and working of solar cell. The solar cell are based on the principles of photovoltaic effect. The photovoltaic effect is the photogeneration of charge carrier in a light absorbing material as a result of absorption of light radiation. Construction: solar cell crystalline silicon consists of a N-type semiconductor emitter layer and P-type semiconductor layer base. The two layers are sandwiched and hence there is formation of p-n junction. The surface is coated with anti-reflection coating to avoid the loss of incident light energy due to reflection. This is the diagram of solar cell: sunlight, front contact, N-type, P-type, back contact, current, anti-reflection coating, transparent adhesive cover glass. How solar cell work? The solar cell sandwich N-type silicon as free electron, P-type silicon as free hole. The absence of electron when N-type and P-type silicon come into contact and active field forms within the cell. Back contact: P-type positive silicon, N-type negative silicon, glass cover. Front contact grey anti-reflective coating. A proper metal contact are made on the N-type and P-type side of semiconductor for electrical connection. Working: when a solar panel exposed to sunlight, the light energies are absorbed by semiconductor material. Due to this absorbed energy, the electrons are liberated and produce the external DC current. The DC current is converted into 240 volt AC current using an inverter for different application. Mechanism: what to do? Mechanism: first, the sunlight absorbed by solar cell in solar panel. Absorbed light causes electron in the material to increase energy, at the same time making them free to move around in the material. However, the electron remain at this higher energy for only a short time before returning to their original lower energy position. Therefore, to collect the carrier before they lose the energy gained from the light, a p-n junction is typically used. A p-n junction consists of two different regions of a semiconductor material, usually silicon, with one side called the p-type region and the other the n-type region. During the incident of light energy in p-type material, electrons can gain energy and move into the n-type region. They can no longer go back to their original low energy position and remain at a higher energy. The process of moving a light generated carrier from p-type region to n-type region is called collection. This collection of carrier electrons can be either extracted from the device to give a current, or it can remain in the device and gives rise to a voltage. Now, the electrons that leave the solar cell as current give up their energy to whatever is connected to the solar cell and then re-enter the solar cell. Once back in the solar cell, the process begins again. The mechanism of electricity production: different stages. The above diagram shows the information of p-n junction in a solar cell. The valence band is a low density band and conduction band is high density band. Stage first: when light falls on the semiconductor surface, the electron from valence band promoted to conduction band. Therefore, the whole vacancy position left by the electron in the valence band is generated. Hence, there is a formation of electron hole pair on the sides of p-n junction. Second stage: the electron and holes are diffused across the p-n junction and there is a formation of electron hole pair. Third stage: in the third stage, the electron continues to diffuse. The negative charge build on emitter side and positive charge build on the base side. Fourth, when the p-n junction is connected with external circuit, the current flows. Advantage and disadvantage applications of solar cell. Advantage: it is clean and non-polluting. It is a renewable energy. Solar cells do not produce noise and they are totally silent. They require very little maintenance, because in this case not use moving part. They are long lasting source of energy which can be used almost anywhere. They have long lifetime. There are no fuel cost or fuel supply problem. But major disadvantage: how to degrade it. In future we use more solar panel, but how to degrade? Solar power can be obtained in night time. Solar power cells, solar panel are very expensive. Energy is not stored in battery. Air pollution and weather can affect the production of electricity. They need large area of land to produce more efficient power supply. Applications: solar pumps are used for water supply. Domestic power supply for appliances include refrigeration, washing machine, television and lighting. Ocean navigation aids. Number of lighthouses in most bios are powered by solar cell. Telecommunication system: radio receivers on mountain tops or telephone box in the country can often the solar power. Electric power generation in space to provide electric power to satellite in an orbit around the earth. PV manufacture overview available for solar panel. There are different websites. Matrix, Isofort, BP, that. PV manufacturer of solar panel, this and other sites. PV manufacturer will be available for solar, PV manufacturer panel and PV solar panel specification. And available in this BAP solar power 170/24 microcrystalline portless connectors. PV solar panel specification 171.99 rupees. Power electronics interface for solar photovoltaic system. We discuss about next lecture, my fifth part. Thank you.